Hello all, welcome to my channel. I'm ready with a new video. In this video, we will discuss what is Flink from the view of a Spark developer. And why I'm creating this video is while I was working in uh, one of the fintech firms, one of the juniors came and asked that I have worked in Spark for last 2 years, and suddenly he was supposed to work on a new system which was for streaming, and he was asking me that okay, how quickly I can understand Flink from point of view if I already know Spark. So that's where I thought, why not create this? Uh, Whatever I have told him, I have documented him this blog. So let's get started. First thing first, what is Flink? Flink is a stateful computation engine over a data stream. It processes unbounded data. That means the data can keep on coming. Spark is a unified analytics engine which has both streaming as well as batch capabilities. The streaming in Spark is nothing but a micro batch. So the major difference here is that although Flink processes data in real time with unbounded data, Spark processes in near real time with bounded micro batches. So this is all about their basic purpose, that why they are used and how they are used. So if someone is coming from Spark, so Spark folks have this mental model that they have a driver, they have an executor, they have cluster manager, worker nodes, and stuff like that. So how does that map with Apache Flink? So Apache Flink has similar to Spark driver, which manages the whole overall application logic, and it manages the task, it manages the job submission and coordination with executors. Similarly, in Spark Apache Flink, we have a concept of job manager. So job manager is an equivalent to driver, and this job manager, it coordinates task execution and schedules tasks. It also manages the fault tolerance. When Then we have executors. So executor in Spark is a JVM process that runs on a cluster nodes, and they execute the task in parallel. Same Something similar is there in Apache Flink with the name called task manager. They are equivalent to an executor. They execute the task, they manage the memory, and handle the data exchange between the tasks. Cluster manager, as we know that Spark can have different cluster managers. Like we can run Spark on Kubernetes, Spark on Yarn, Spark on standalone, Mesos. So each of those have certain with a defined cluster manager. Yarn and Kubernetes being the most common ones. Same in Flink, we have resource manager, which is nothing but similar to what cluster manager does in Spark. And Flink also is supported on Yarn and Kubernetes. So those are equivalency in there. Then the worker nodes is in Spark is where the executors are hosted. Same way, we have worker nodes in Flink, which host task managers. So that's the equivalence. So basically, if you see these things like cluster manager, worker node, these are distributed compute concepts. So these remain same because both of them are distributed compute engine. Flink has a concept of task slot, which is that each task manager has a configurable slots, and each slot can each slot can process a unit of task, and multiple tasks can run concurrently with a single task manager. In execute in Spark, we don't have explicit task slot. What we say is, for example, if we have an executor and we have given 5 cores to it, so that becomes the parallelism of that particular executor. So that means that executor can process 5 tasks in parallel. That means it can process 5 partition in parallel. And in Flink, that is the equivalent of task slot, because but that task manager has a very the slots are very configurable. It is not as hard coded as the one in executor, where the number of cores decide how many parallel tasks run. So this task manager has configurable slots, and we can decide how many slots we want for an executor, for a task manager, and then how many tasks run on parallel. So pictorially, if we see, This is the equivalence like Spark and Flink. So we have driver, which is mapped to job manager, executor, which is mapped to task manager. In Spark, defined. Tasks are something which is a parallel unit of work, works on a one particular partition. So here, what happens is Flink has a concept of operator. So all the transformation that we do, for example, let's say we are doing some aggregation, some filtering, something else. So all the operation that is happening. So Flink does everything with the operator chain. So each operator's instance is called as task, and they work on input split. So as how Spark task works on a partition, the operators works on the input split. So input split is a part of a input data that has come, so that it processes that particular data. So this is how it's all refined. There is no stage per se in Flink. The reason for that is there is no why Spark does stage split is to manage the shuffle and movement of data. But Flink being a real-time engine, it always moves data from one task to another task. So there is no split of stage happening in Flink. So that's one major difference. Now talking about the programming model primitives which are there. So as we have seen, jobs in how a Spark application is divided is into jobs, then stages, tasks, partitions, DAG. So similar concept is there in Flink. So what is once we call an action in Spark, there is a job that gets created. But in Flink, there's a job is nothing but a data flow graph, which represents the entire computation which will happen. There is no stages in Flink as I mentioned earlier. So data flow graph is nothing but operator chain, and they run in parallel. Execution is pipeline, so there is no division of stages. Task, as we discussed in Spark, executors do unit of work as a partitions reference, and each partition is processed using one task. So that's task part in Spark. In Apache Flink, unit of work is executed by task managers, and uh, sub, they are an instance of the operator which called them, and they work on the input split. Partitions, as data in Spark is split into partitions, which is in-memory representation of that, and in Flink, data is split into subtasks based on parallelism, and each subtask processes a portion of the data and the data set. And stream partition or input split is what we call in streaming case we call it stream partition, while in the batch mode we call it input split. That defines the parallelism in Flink. DAG, which is a concept in Apache Spark, which says that it is a directed acyclic graph to represent the whole computation divided into stages and tasks. And DAG scheduler uses this DAG to optimize and create a physical plan out of this. Flink uses job graph, which is again nothing but a logical representation of all the data flow that happens through the operators. And job graph is optimized and then executed by the job manager. Execution flow, how it happens in Spark is starts with driver creates a logical plan, then micro batches are created, stages are created, and then tasks, and then those tasks are sent to executors, and executors execute them and return back the response to the driver. Something similar happens in Apache Flink. The job manager starts with the job manager creates a job graph, then that translates into execution graph. Then execution graph is split into multiple tasks. Each task manager is given a task, and that task manager sends that task to an operator chain, which is a pipeline, and that gets executed. Execution mode, stage by stage, it is what happens in Spark because we have multiple stages. Each job is divided into multiple stages, and then each stage is executed independently. So yes, we have execution mode. We can say it is stage by stage, but in case of Flink, there is no stage creation. It is all one pipeline with a chain of operators. So the execution mode in there is operator by operator and record by record. So because in Spark we have stages and the data from one stage is moved to another stage. That is using the shuffle barriers. We have a shuffle barrier. Not data movement happens through shuffle barrier, but shuffle barrier is just to say that okay, we have a stage. So uh, Spark processor records in batches, so it doesn't operate on one record at a time. It processes the records in batch, while in Flink, the processing model is record by record. Uh, Actions. So in Spark, there is a concept of action which just triggers work, which gets translated into a job. There is no explicit action in Apache Flink because a Flink has to process data in real time. So there is no, it doesn't wait for an action to be triggered. So it's always on. So there is no concept of action in Apache Flink. Transformations are there in Spark. So the transformation in Apache Spark are lazy. Lazy, when we say it is, it simply means that they are not executed at the moment we create it. When the moment we define it, we have to take an explicit action, and that's the time when if we have multiple transformation, they get optimized and built into one optimized physical plan and then gets executed. uh, in Apache Flink, we have concept of transformation like map, filter, key by. So that is defined in the data flow, and Flink transformations are compiled into job graph and then they are executed eagerly. Eagerly means the moment we say, let's say we say that we are doing some transformation, it will not that okay when we call an action then only it will trigger. It get triggered immediately. So there is no waiting happening. uh, as Spark has a lot of stages, so there is a data shuffle that happens. Data exchange in Flink is between tasks because each task does need the records to be available for them to process it. So Flink has shuffle, but it is not that of a challenge like Spark. And the shuffle happens in the pipeline execution. Compared to Spark stage-based shuffling, it is low latency. So there is no stage boundary as well. Scheduler, which schedules the stages and tasks on the parallel executors per DAG in Spark. So the same work is done by job manager in Apache Flink. Checkpointing. So in case of structured streaming, we can enable checkpointing. We can define the checkpoint directory in Spark, which takes care of maintaining the state in durable storage. In case of Flink, the checkpointing is inbuilt. We don't have to enable decide it ourselves. It is coordinated by job manager and persists the state on the local disk every time. Then we have state store, which is again we Flink, sorry, Spark when it works with structured streaming, it does maintain state. I think it uses RocksDB as a custom state handling is needed. And in Flink, it is native, fault tolerant, and it is also a keyed state, operator state. They are all embedded and they are stored in a local disk. So this is some what you called a similarity of what translates to what in Apache Flink. Then let's take a pipeline example that how a pipeline from Spark streaming or Spark streaming maps to pipeline in Flink. So as we said, let's say in this example, what we will do is we will read stock data, stock price data from a Kafka, perform a group by operation to calculate the average stock price over a 1 minute window, and then write it the results to an operational sync. We will do this both in Spark structure streaming as well as in Flink to see how the things are different. So this is flow in Spark, we will have multiple stages. Two stages are there. Stage one, stage two. There is a shuffle, and but in case of Flink, there is no stage. There is no shuffle. Although there is some chaining is there, but there is no shuffle. So this data, there is no stage boundary as well. So see, Kafka source is read. In both cases, they both deserialize and parse. They both create the window of 1 minute. But here, Spark creates a stage and then suffers the data to the next stage where group by is done. Here, the operator chain is there. The data is actually moved from this particular operator to the key by operator. So one thing, if you see here, it is called group by. Here it is called key by. and then average price is calculated and then persisted to sync. But this persistence to sync is happening in this particular stage. Here it happens in a different operator. Code wise, if you see, this is a PySpark code. Basically, what we are doing is first we create a stream to read the Kafka data. Then we do the watermarking, group by, and average price calculation, and then we write it to OpenSearch sync. In PyFlink, so this was PySpark. I wrote it in PyFlink with table API. It is something similar. If you see, we created the environment, we created the Kafka source, we read the Kafka details, then we created a temporary table on which we are running the window operation. Um, sorry, yes, we create the window start, window end. We created it, and then we process that result to here we are presenting that to OpenSearch sync, and then we wait. So this is how we create. We can create a Spark Flink job which is based off a PySpark sub. So this is one-to-one mapping kind of thing. So this was it, and hope this was helpful. So if you are from Spark and you want to start with Flink, this was a good place to understand what is there in as a common, what is there as a difference, and how we can quickly. It's if you see the code, it is not that different from in Spark streaming versus in Spark Flink code. So it is straightforward and good to know. So that's all from this video. Uh, we'll see you in another video. Thanks.